All right, so you should all have the notes in front of you, yes? Okay, so 2.3, we're looking at sinusoidal models. All right, so we learned how to look at sinusoidal functions, just at sine and cosine, and now we're going to look at how to model with them. So example 1 is very similar to the last 4 problems in your problem set, where we're writing the equation of the graph, but it's a little bit more difficult. The ones on the problem set, I think you only had you didn't have any phase shift changes or midline changes, I don't think. And so on this one, you do have phase shifts and midline changes. All right, so it's a little bit more difficult to see that. But you do the same thing that I did when I just did those problems on the problem set. What's the first thing that you do? You go through and you identify all the 4 important pieces: the amplitude, the period, the phase shift, the midline. You do the exact same thing with this graph. So you pull those pieces off the graph, and then you put them together in the equation, okay? So first of all, what I look for is, I kind of typically start with the y changes. So I look at the amplitude and the midline. So you can kind of see, if you kind of graph this out, you can see that I have a maximum here and a minimum here. So then if my maximum is at, what, 5? Y value of 5, right? And my minimum is at a y value of -1. Yes? So what's kind of like, so that's my range from -1 to 5. So remember that we didn't do much with this last class, but on 2.2 notes, I had the definition of the amplitude as 1/2 times the difference from the maximum and the minimum point. Okay, and that's exactly what you do. So the difference between the maximum and min, that's a distance of 6, right? So then the amplitude would be 3. Okay, so if you want to write that out, you can. You don't have to, you can just see it. But if you want to write it out, it would be 1/2 times the maximum point minus the minus the minimum point. And so that would be 1/2 of 6, which would be 3. So there's my amplitude. Okay, so the next would be my midline. That's typically what I do. I know that's kind of out of order of the A, B, C, D, but that's what I typically do is I do the y values first, which would be the amplitude and the midline, and then I go back and do the x values, which is the phase shift and the period. Okay, so the midline, how you get that, and I know it's kind of easy to see on this one, but when we get into really kind of gross numbers, it's good to kind of have a process. So the midline, you can either take, if you know the amplitude, you can either take the maximum and subtract the amplitude, right? Or you can take the minimum and add the amplitude. I typically take the minimum and add the amplitude. So my midline would be taking the minimum and adding the amplitude, which would give me 2. Or you could take the maximum and subtract the amplitude, which would also give you 2. All right, so then I like to go ahead and show that on my graph, the midline, to make sure that that makes sense, and it does.
Can you also just look at it?
You can also just look at it, because this one's easy numbers, yes, you can look at it, but that's not always going to be the case, so I'm giving you a process. All right, so amplitude, midline. Let's look now at period. Okay, when I look at the period of a graph, what I like to do is I actually like to look from high point to high point or from low point to low point. Because remember, period is how long it takes to do a full cycle. So it's easy to see those high points or those low points. So I'm going to go high point to high point. So this is kind of like notes. So it's taking down the process and make sure you understand the process. Or you could do low to low. It does not matter. Okay, but I see 2 high points, so I'm going to do the high points. So I go from this is my high point to this is my high point. All right, and we're looking at x values. So just like I did with the amplitude, I'm going to do the same thing with my x values. So what's the x value of this first high point? -5. What's the x value of the next high point? 19. Okay, so that's a distance of 24. Yeah. So it took 24 units to get back to its original spot, and so that is going to be my period.
So disregard negative.
Correct. Well, not disregard, it's the distance. So it's 19 minus -5, so you can't just disregard the negative. So it's 19 plus 5. Yeah? Okay, so then my period for this one is 24. Now, remember we're writing the equation. So the amplitude and midline, those go directly into the equation as A and B. but the period is a little bit different. 24 is not going to be seen in my equation. Remember, how did we get the period? If I gave you b, how did we get the period?
It's 2 pi over.
Correct. The period was calculated as 2 pi over b. So then if I know my period and I'm trying to get the b value, it's the same thing, right? If I solved this for b, b is 2 pi over the period, yes? So it doesn't matter. You do the same process in both because they're inversely related. Okay? So if I'm giving you the period and I want to find the b that goes in my equation, you just simply take 2 pi divided by the period. Okay, so b is equal to 2 pi over 24. Does that make sense? Any questions on that? Okay, so we have our amplitude, we have our midline, we have our period, or our b, sorry, our b. And now we need to find the phase shift. Here's where it's important to understand that sinusoidal graphs are not unique. I could come up with an equation, and Natalie could come up with an equation, and they could be different and still be both right. Why?
Maybe you can do sine and cosine.
It could be sine or cosine. And also, you could, if I chose cosine, you could start here at this high point. You could make it start here at this low point. You could make it start here at this other high point. So I could have like 3 different versions of cosine based on where I start. Okay? Sine is a little bit harder to see because sine starts on the midline. So sine, if I were to start there, the midline would have to be, I'm running out of colors, the midline, or sorry, yeah, it would have to start here. Does that make sense? Which is sometimes difficult to see. So a lot of times when you're doing sinusoidal models, a lot of times we're going to default to cosine because cosine starts at the higher low point and it's really easy to see the high and low points. Okay, so I'm going to give you 2 examples here. So I'm going to kind of erase this a little bit so that I have a clear graph. So we have this point, which was on the midline. So if I start on the midline, that would be looking at which function? Sine. Okay, so if I start on the midline, so I would have a phase shift of 1, right? Because it moved to the right 1. Okay, if we're using the sine function. Now, if I started with this leftmost high point, that would be starting an amplitude. So that would be what? Cosine. And what would be that phase shift? -5, if cosine. There's actually another possibility. There's actually infinite possibilities. We typically like to choose the ones that are closest to the y-axis. That's typically what we do. It really doesn't matter. But could I have also chosen this point? Yes. What would that phase shift be? Phase shift is of 7, but what function would I be using in that one? More specifically, negative cosine. Correct. Negative cosine. So there's 3 different possibilities. I could even do this last one, all right? So your answers are not going to be unique. I normally default to cosine because it's easy to see those highs and lows, and I normally go to the one that's closest to the y-axis. All right, so if that was the case, we would use what I have in green, and we would do that cosine graph. Yes, ma'am?
So to determine like the phase shift for the cosine, you just look at the highest point.
And it's x distance away from the y-axis. Correct. Yeah. Everything else is the same. So on all these graphs, this green, this red, and this purple, everything else is going to be the same. The amplitude is the same. The period is the same. Everything is the same. It's just the phase shift is going to be different. Okay. So let's do that green one. So the green one, let me use green, is going to have, it's going to be positive cosine because we're starting at a high point. And what's going to be the amplitude? 3. So we're going to do 3. We're using cosine. And then we have our b of pi over 12 times x minus my phase shift, which would be +5, and then plus my midline of 2. I want to make sure we all understand that. Just put all the pieces together. Any questions? Okay, I want you to go ahead and write what the equation would be if we had used sine, so the red one. All the pieces are going to be the same except for the phase shift and it being sine. Everybody good with that? Yeah? Okay. So on your problem sets, when you're doing these, you might still have the right answer. It might look different than mine, but you still might have the right answer. So I'm going to let you guys use your calculator to check. You can put that function into the calculator and you can check to make sure it's the right graph. Okay? All right. Moving along. Example 2. So same kind of deal, but instead of giving you a graph, I've given you information about the graph. All right, so it says the sinusoidal function has a maximum point of 2, 5, and the next minimum point at 9, -1. That is all the information you need to write an equation of a sinusoidal graph. You just need a maximum and the next minimum. That's it. You can figure out everything from that. Okay, so I'm very visual. I like to see it. So I'm going to go ahead and graph it, and so get a good picture of what's going on. All right, so let's graph this. 2, 5 to 9, -1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 5, 9, -1. Okay, these actually had the same max and min values, just at different x values as the first example. We had a max of 5 and a min of -1 in the first example. Not very creative, am I? All right, so then the first thing that I would do is, just like we did before, is I would find, okay, what is the range from the top to the bottom? What's that distance? 6. Okay, and so the amplitude would be half that. The amplitude would be 3, correct? Okay, if the distance from the top to the bottom is 6, then the amplitude is half that. Okay, so then for the midline, so D. The midline is the minimum point plus the amplitude. I'm just putting for notes, I'm going to say that that was half of 6. That's how we got that 3. So to get the midline, the D value, we just add our amplitude to our minimum point. So then I'm going to go ahead and put in that line, which should be halfway between those 2 points. Everybody good so far? That was the same exact thing that we did in the first one.
D is the midline.
D is the midline. Okay, now for the period. Okay, am I seeing from a maximum to a minimum point, am I seeing the full period? I'm only seeing half of it. Correct. Okay, so if I measure the distance from the first point to the second point in the x direction, that's going from what, 2 to 9? So what's that distance? 7, and that's half the period, correct. So my period is equal to twice that, which is 14. Now, is that the number that's used in my equation? Am I using 14 in my equation? No. B, remember, is 2 pi divided by the period. So I'm using B, so I need to find 2 pi divided by my period of 14. So B is going to be pi over 7. And then finally, the phase shift. Okay, what makes sense? What function makes sense to use in this example? Cosine, right, because I can clearly see that maximum point. So if this was cosine, so it would look, you know, something like this, right? So that would be my starting point for cosine. Sorry, my handwriting is not very good on this. Okay, so that would be my starting point, so what would be the phase shift? It would be to the right 2. Yeah? Okay, so let's put this all together. So we would have y equals, you tell me, 3, not times, of, it's important. X minus 2, careful there, yeah, and then plus 2. Questions?
Yeah, so like with the period thing,
Mm-hmm.
like why do we have to do that?
Because remember that, so our period of regular sine and cosine functions are 2 pi, is 2 pi, right? And so that b, what that does is it's a horizontal transformation. So remember from when we were graphing, if I gave you b in the equation, then the period is affected by a factor of b. So to find our period when we were graphing, we would take 2 pi and divide by b, right? And so when we're looking at graphs, we don't see the b value, we see the period. And so we need to figure out, okay, what was the factor that we used to stretch that period by? So you have to take 2 pi and divide by that period. Okay, any other questions? Okay, we're actually going to skip example 3 and move on to the back.